James, the Justice and Mercy Engineering Society. Part 5.1 is on lead-acid battery chemistry. Lead-acid batteries are the type of batteries most commonly used with solar photovoltaic systems. As a model for the lead-acid battery, let's consider this jar full of electrolyte. And in the electrolyte are two electrodes, the cathode and the anode. The cathode is covered with a lead dioxide paste, and the anode is covered with a lead paste. And the electrolyte on a fully charged battery or a fully charged cell is sulfuric acid, H2SO4. And when you build this configuration, they will naturally measure a voltage between the anode and the cathode of 2.2 volts. Now, that's a fully charged battery. A fully discharged battery, the electrolyte is now mostly water. And the same two electrodes, the cathode and the anode, are covered with another substance, lead sulfate. And that's both the cathode and the anode are covered with lead sulfate. And lead sulfate has two forms, and the amorphous form is easily soluble, and there's another more inert form that we want to stay away from. Now let's look at one cell. One cell, we said, if it was fully charged, which is 2.2 volts. If it was discharged, it's about 1.75 volts. Now if we put multiple cells together, that forms a battery, just like we might have a battery of tests. In this case, we have a battery of cells, each one at about 2.2 volts when they're fully charged. And so if I put all 6 of those in series, it gives me about 13.2 volts. Now we normally call this 12 volts because it's 6 times 2 is about 12, and there's other configurations too, 6 and 24 and 48, all in one battery, one collection of cells. Now we have to keep the walls of these individual cells from leaking electrolyte from one to another. So if we let them leak together, they become one cell. So we have to keep the actual liquid electrolyte from mixing. So let's talk about where the energy is stored. The energy is actually stored in the chemical bonds in the electrolyte. So when it's sulfuric acid, there's lots of chemical bonds that have energy in them. When it's down to water, then most of the energy is released. So let's connect and imagine an electrical load, some type of resistor, a lamp, if you will, in between the cathode and the anode, and positive current is going to flow from the cathode to the anode, which means electrons flow the opposite direction. Now, as the cell moves from a state of being fully charged to being discharged, it's giving up energy. And what the chemical reaction is doing is the H2SO4 is reacting with the electrodes and forming a sulfate, PbSO4, layer on the two electrodes. That's what those little round circles were. Now, let's look at the detailed chemical reaction here of lead and sulfuric acid, or at least an ionic form of sulfuric acid. It produces 2 electrons. That's where the electric current comes from those extra 2 electrons. And then on the cathode with the lead dioxide, it's a slightly different reaction, but that reaction requires the excess of 2 electrons that come into, and so we see that the electrons flow from one electrode to another, and that process is where the source of electricity comes from. This process continues on until all the surface area, or the usable surface area of the 2 electrodes, is covered with lead sulfate.